Okay, so today we're going to talk about logs, and so we'll start with the definition of what is a log. So if you take an exponential equation, b equals a to the x, sometimes we want to get it out of the exponential, and that's where logs come in handy, as it gives us that opportunity to get rid of exponents. So a couple of things that need to happen. First of all, a cannot equal 1. Okay, a must be bigger than 0, and b must be bigger than 0. So no negative numbers as we're dealing with this. Notice you can have negative exponents, but a and b cannot be negative. So if we have this, in order to get it out of an exponent, we're going to use something called a log. And this is what the equation looks like. This is the formula. You're going to want to write this down, and hopefully at some point you'll memorize it, mostly by using it. But x, so our exponent, is going to equal log a is going to go down here. This is a subscript. It's so it's basically log base a of b. All right. So if we have the equation b equals a to the x, our log equation is x equals log a b. So we're going to do lots of examples with this, but this is our basic equation. So make sure you write this down. Make sure you have this so that we can solve the next few a little easier. So we'll start with some easy ones. Let's say that I have 3 to the 4th equals 81, and I want to write that using logs. Well, if you remember correctly, our a goes down here, and our b goes on the other side. So our a goes down there, our answer, our b goes there, and our exponent becomes our answer equals 4. Okay? So we'll also do, so I was going to do more than one example, but I think just one is fine like that. All you have to do is put it back in the formula. Remembering the formula is a to the x equals b. So it's log a b equals x. All right, moving on. The next type of problems that you're going to have to do, or if you're given a log equation, log 10 equals 100, what does that equal? Okay. All right, I'm going to give that a variable to make it simpler to deal with, so we're going to call this n. Okay. Your book will not say that. I just picked n. You can pick any variable you want. You can pick x, y, z, whatever. I don't care. All right, I'm using n. So when we do that, we're going to rewrite this saying 10 to the n equals 100. Okay, and this is where your math skills come into play. We know that 10 to what power is 100? Okay, n equals 2. 10 squared is 100. So you have to know, so there's some knowledge that you have to have before you can solve these. All right, so let's try with this a little bit harder. Let's go log 5.2 equals whatever. Okay, again, we're going to call that n. Okay, so again, I'm going to go 5 to the n equals 0.2. Now, at the offset, it looks like this is something that I can't do, but I'm going to change this 0.2 to a fraction. 5 to the n equals 1/5. Okay, again, you need to look for the pieces that might make sense. Okay, if it doesn't look like it will work in one form, try another form. Okay, well, I know that 5 to the n equals 1/5, that n equals a negative 1. So, and that's from all of my exponents. Okay, moving on. Now, there are going to be some questions that you can use your calculator for. Just so you know, anything that has a log, change this. Log with a base of 10, okay? When you, on your calculator, you will have a log button, L-O-G, that calculates with a log of 10. So if you have a problem, oh, I didn't do any examples. Okay, let's say I have a problem that's log 10 of 12, okay? I can put that into my calculator, just log 12, and it will spit out an answer, and you'll have to forgive me, I did not put an example on this, so I have to go grab my calculator. So now in my calculator, I'm going to put in log 12, okay, keeping in mind that the base, this base right here, okay, that's already figured in, okay? The calculator, the log button always means base 10. So I do log of 12, and I get an answer of 1.079, and it keeps going, but I'm just going to use 3 decimal places. So that should be fairly easy. There's problems on your homework that asks you to do that. All right. Last part. These examples are probably the hardest. No, I'm sorry, I lied. There's 2 more parts. So, we're going to start with what happens if we have a piece missing. So I have log 3 of x equals 5, and it wants me to solve for x. So to do this, I set it up. Remember the a to the x equals b. Unfortunately, the x in this equation is 5. That's my exponent. So it's hard when they put these different letters in here. This is a formula, this is a problem. So what I'm looking for here is actually this to be b. Yeah, this x should be b. So my problem says 3 to the 5th equals b, or x, which is in the problem. So 3 to the 5th equals 243. So there's several problems like that. Those ones shouldn't be too bad. Next problem. Now these ones are kind of tricky. These are ones where you have to know your exponents again. So I have a log base 2 of 16. And there's more than one way to solve this, but I want to point out something that's interesting. If I have this log base 2 of 16 and I want to figure out what the answer is, there is actually something very interesting that happens. Let's say I have log base 2. I'm going to change this to a power of 2, 2 to the 4th. And when this happens, when your a and your x are exactly the same, they will cancel out. So these two cancel out, and so my answer is 4. So that's what these kind of problems are asking you to do. They're asking you to figure out how to cancel out the log. So do another one. Say I have log 10 of 100 to the 1/5 power. Okay, again, I'm trying to get rid of the log itself, so I'm going to change the 100 to a power of 10. Log 10, 10 to the 2 times 1/5, okay, which is 2/5. Those cancel out, and my answer is 2/5. One more. This one's a trickier one. I'm going to have log 2, 1 over the square root of 2. So there's a couple of different things going on here. First of all, we need to get rid of the fraction, and we can do that by using negative exponents. And the second thing we need to do is to get rid of the radical, which we can do using fractional exponents. So when I do this, the square root of 2 equals 1/2. Okay? So my and now to get that out of the exponent, I need to make it a negative. So it's log 2 of 2 to the negative 1/2. So these cancel out, and my answer is negative 1/2. Okay. I know this video was a little long, but I am finished. I will post the homework on Edmodo.